In this video, we will discuss how design parameters are broadly generated, and then used during computer-aided engineering. This will provide a culmination of all the content we have previously discussed, and show you how they all work together. Due to the fact that this course is focused on using the fundamentals of design and optimization, we will not delve into the process of creating the problem parameter ranges from the problem statement, using simulation or data analytics. That process is a course in itself, so for now, we will work from the problem parameters. The parameters are dependent on the conditions that the design is meant to withstand. They also dictate the physical requirements of the design itself. As a result, the parameters are directly applicable to multiple steps in the process, like so. Once the parameters are properly defined and established, the next step is to take the parameters and develop all the individual features using feature-based modeling. Once all the features are developed, they are combined/amalgamated using the operations in Boolean-based modeling. Finally, once we have a general blueprint for the different features and how they are put together, we can use the part parameterization to appropriately size and develop a model that would fit all the requirements needed to satisfy the application. Typically, problem parameters are dictated so that the part parameters need to be within sets of ranges. Working with these ranges will be completed with more detail when discussing unconstrained versus constrained optimization, and later when completing sensitive parameter control. With part parameterization completed, the first half of the combined design and optimization process has been completed. This first half of the process is computer-aided design, otherwise known as CAD. With the design complete, the next step is to complete the steps for developing the optimization problem. Based on the finalized design, we now have the discrete sets that define the geometric shapes and the continuous behavior between each discrete point. Once we have defined the requirements for completing continuous and/or discrete optimization, we can move forward to adding constraints and/or penalty terms, if applicable. The question of whether or not to use constrained/unconstrained optimization comes from the ranges that the parameters are allowed to fall within. Once we know whether unconstrained or constrained optimization applies, then we can move on to whether or not we use deterministic versus stochastic optimization. The need for using deterministic or stochastic optimization depends on the reliability of the information we have, be it based on the potential for errors in the problem statement and application conditions, or even the potential for future errors during the manufacturing stage. With the optimization problem properly defined and able to be solved, this completes the computer-assisted optimization process, otherwise known as CAO. With the parameters defined from simulation or gathered data, all the design definitions, characteristics, and behaviors defined via computer-aided design, and the optimization problem fully defined via computer-assisted optimization, we have now completed an iteration design generation using computer-aided engineering, also known as CAE. Oftentimes considered to be the future of product development, computer-aided engineering enables more agile product innovation and design. By improving the availability of designing and even testing different products without completing physical tests at first. A perfect example of when CAE became vital is during the COVID-19 global pandemic, where ventilators and face shields were developed with minimal experimentation. Where previous product development and validation needed experimentation, CAE brings the ability to reduce the number of physical tests that need to be completed. By using mathematical modeling and existing experimental results of related phenomena to predict theoretical test results. In consequent videos, we will discuss computer-aided engineering from the perspective of completing generative design and optimization using design iteration, and we will discuss how to isolate the parameters that are best for optimizing. Thank you for watching this video. See you in the next video.